guys, thanks again for tuning in with InfoSec Pat. In today's video, we're going to be talking about introductory of networking on TryHackMe. This is supposedly a good room to get the fundamentals of networking. I connected to the VPN. I'm starting up my attack box, so we'll get that open up shortly. So to access this, if you are unsure how to access it, you just go to Learn, and you can obviously browse around, so all that good stuff. So I just went to search. I just said free subscriptions only because this is the free subscription. I don't have the premium. So, and then I just went to easy just because it's an easy room. So in here, you're going to learn about, let me just make this a little bigger. You're going to learn about networking, the OSI model, networking tools, and this is, a part of the beginners track. So why am I making this video, right? I think this video is definitely important to know because entry level students or entry level folks that want to get into, for example, pen testing or ethical hacking or even networking in general, like Network Plus, CCNA, any kind of networking certifications, having that fundamental understanding is super, super important. So this room is for that, right? Introductory of networking. This is an introductory to networking theory and basic networking tools. So it's about 9 tasks. Hopefully it doesn't take a long time. So, if you guys are new to the channel, welcome. Thank you so much for checking it out. I have so many other videos. Check them out. And if you have any recommendations, feel free to hit me up and I'll take that and run with it. So there's a whole bunch of words and jibber jabber um, on these tasks. I'm not going to read everything out. Once you open it up, you can read it. I'm just going to go over it high level. So the introductory, the introduction, pretty much this room is aimed for beginners and basic concepts of networking, right? The basic principles. So what we're going to do here is I'm just going to go ahead and hit complete. And woohoo, it answered the question. So I did connect to the VPN. Like I said, I connected to the VPN, download the file. And then if we do show split screen, we can see our attack box once it's up and running. So we can hit enter here to exit that. And if we do a little if config here, if you guys are not familiar with these commands, don't worry. We'll explain a little bit more. This is just going to show the IP configuration for this box. As you see, 10.10.54.201 right here, 10.10.54.201. Okay, perfect. So we completed the first task. So it's pretty much this is going to be when we're talking about the the OSI model, the TCP IP model, how these models look in practice, and an introductory of the basic networking tools. So that's task numero uno. Now let's go to task number 2. Okay, so this is when it's going to get a little more tricky and a little more in depth, right? We have seven layers of the OSI model. We have the application layer, presentation, session, transport, network, data link, and physical. These are all the 7 layers. So what is the application? What is the presentation, etc.? So if we see down here, we can see a brief overview. The application layer is at layer 7. This is pretty much the application layer, and this is what provides the network options to programs running on a computer, right? So, and like I said, I'm not going to sit here reading it. I'll give you the overview, and so we can just get to the answers and questions, etc. Because this is a walkthrough of this room, so I'm just going to keep it brief. The presentation layer, right? The presentation layer receives data from an application from the application layer. So what does that mean? That means so any data that traverses, it's going to go ahead and format that application so it understands, like it says, but it's not necessarily in a standard format that can be understood by the application layer in the receiving computer. Okay, so session layer, the session layer is pretty much going to go ahead and receive the formatted data from the presentation layer, right? So transport layer, this is where TCP/IP UDP, TCP, and UDP. Sorry. So, like I said, this is a lot to read. You can go ahead and read it and get a better understanding. The network layer, this is where like routers, IPv4, IP addressing runs at. So you'll probably hear people saying, "Oh, it's a layer 3 switch or it's a layer 3 device," which means it's a router that's able to forward packets off its local network. Okay? Then you have the data link, which is layer 2. This is pretty much, you will see a layer 2 switch. This is will focus more on the physical addressing, which is the MAC address, you know? And what is a MAC address? It's it's inside of a network card. It's a physical embedded or like burned in address that it cannot be changed. But there is ways to manipulate that with MAC changer. But that's more if you get into the ethical hacking world and you want to go ahead and anonymize yourself and all that good stuff. Let's start out the basics, right? So like it says right here, MAC addresses are set by the manufacturer and literally burned into the card. They cannot be changed. Okay? And layer 1, this is the physical layer. Maybe it's a wire, Ethernet, an Ethernet card, the Ethernet cable, Cat45 cable, and or Cat5e, okay, or Cat6 or whatever. So now we can go ahead and get into the questions, right? So I know I did that pretty quickly. I just didn't want to spend all the whole time. So we'll go ahead and read the question, and then we can go reference to the layers. So which layer would choose to send over TCP? So if I remember correctly, that will be layer 4 because it's going to go ahead and transmit that data over TCP. Okay, so if we put 4 here, hit submit, bada bing, bada boom, we're good. Okay, so which layer checks packets to make sure that it hasn't been corrupted? That's going to be layer 2, right? That's going to be the layer 2 of the switch. This is what layer 2 is for, right? So let's go ahead and hit layer 2 and woohoo. All right. So which layer would the format of the presentation to be transported? That's also layer 2. All right. Additionally, right here, presentation data to be suitable for transmission. Okay. So that's layer 2. Okay. So this one is going to be which layer transmits and receives data. That's going to be layer 1. Okay. So if we can see here, layer 1, this is going to go ahead and transmit the data right here across the signal, across the wire on the network. Okay. So which layer encrypts, compresses, and otherwise uh, transmits the initial data to give it a standard? I think that will be layer 5, right? No, I thought it would be layer 5. Let me see. See, this is layer 6. That's my bad. Layer 6. Yeah, I apologize for that. Whoops. See, this is why we're doing this together. And this is all from, you know, right off the top of my head. I'm not doing no fancy business. Okay, which layer tracks communication between the host and receiving computers? I think that's layer 5. Yeah. Okay. So which layer communicates which layer accepts communication requests from the application? I think that's layer 6. No? Is it layer 5? No. Transmits and accepts. All right, let's go. Uh, which layer accepts communication requests from an application? I think that was layer 6. Um, Presentation. Layer 7. Layer 7. Let's see layer 7. Okay. Guess I gotta brush up on my the OSI model as well. So all good. So which layer handles logical addressing? That's layer 3. I think I should know that one. Yeah. So when sending data over TCP, what would be called byte size and piece of data? So that's segments. Segments. Yeah, That's segments of data, right? So research. Okay, so let's see, which layer would the FTP protocol communicate on? That's gonna be layer 7. Okay, let's hit hint. FTP is a protocol, so I believe it's layer 7. Yeah. Okay, perfect. All right. So which transport layer protocol would be best suited to transmit live video? I would say that would be UDP because we don't care about you know because there's connection lists, which is UDP, and it's connection, you know TCP. You have to make sure you have an established connection. Okay, so that section is done. Let's go ahead and do encapsulation now. So let's see what we have here. So as I said, we don't have to read all this. Let's just, maybe if I would have read the first half, I would have been probably a little better at those answers. But let's see if we can just quote unquote wing it, right? So we can just put stage 1, application layer header is added, presentation. All right. So we'll just look at this. So data frames, packets, segments, data. Okay. Let's just go. Let's just shoot for it, right? So how would you refer to data at layer 2 of the encapsulation process? Okay, so that's a good. So when you do layer 2, you have what's called frames. Frames, I would say it's frames. Let's see. Whoops. Yeah, and that's probably somewhere in here. So data is frames right here at layer 2. Okay, so at layer 4, it's going to be datagrams. So it says, how would you refer data to layer 4? I would put datagrams. Boom. All right, this is a little easier. Let me not jinx myself. All right, number 3. What process would a computer perform on a received message? So when we're getting a received message, that would be, because when you send it, you're going to encapsulate that message, right? When you process it from the receiving end, you're going to de-encapsulation. So let me just make sure. Sorry, let me just make. I just want to make sure that's correct, but de-encapsulate. Okay, so computers follow the process of encapsulation to send data and de-encapsulation upon receiving it. So yes, copy this. So it's going to be de-encapsulation. Boom. There we go. We're on a roll. All right. So which is the which is the only layer of the OSI model is to add a trailer during encapsulation? I think that's a data link. Let's just look. Uh, you know what I'm gonna do? I'm gonna do a little. I'm gonna do a little this and then Control F and then paste. So let's see, data connection. See, let's see if there's any more. Okay, so I believe it's a data link. Let's see. Yes. Okay. Cool. All right. So does encapsulation provide an extra layer? No. Uh, does encapsulation provide an extra layer? I guess yeah, it does. I guess we can say yeah. Okay. So let's go down to the TCP/IP model. Okay. So this is going to be the next section. So we have the TCP/IP model, application, transport, internet, network interface. So there's 4 layers of the TCP/IP, and there's 7 layers of OSI. Like I said, this is a lot of reading. This is going to be like when you send a 3-way handshake, or when a 3-way handshake is in play, you're going to send a SYN packet. Then the server is going to go ahead and send a SYN ACK, and then you acknowledge that from the client. So my way to best Frank, SYN actor. I guess that's supposed to be okay. Fair enough. So this is a history to understand exactly why TCP/IP and the OSI model was originated. Okay, why it was created. So let's go ahead and just start the questions and see how far we can get. So which model was introduced first? The TCP? Yeah, that I know that. TCP, TCP/IP. Okay, so which layer of the TCP/IP model covers the functionality of the transport layer of the OSI model full name? So it's going to be transport, I believe. Transport. Yeah. Okay. Cool. So which layer of the TCP/IP model covers the functionality of the session layer? Okay. So the session layer, I believe, is the application. Yes, the application. APP. I see. Application. Perfect. All right. So far we only got a couple wrong, but we were able to get through them. The network interface layer. So that's going to be the network interface layer, the data link. So that's going to be the physical. Okay. Okay. So which layer of the TCP/IP model handles the functionality of the network layer? So that's going to be the internet, right? Internet. Okay. Perfect. We're on a roll. So far, so good. All right. So what kind of protocols is TCP? Remember, I was saying this is connectionless. Connection based. So I believe that's going to show some. Let me just see if we hit hints. It's connectionless. Yeah, it's connection based. Okay, perfect. I believe. Let's see. Connection. I'm guessing it's base. No. Let's see if it's based. Yeah. Okay. So I guess we needed to do the little dash. So when is SYN? What is SYN short for? So that's going to be synchronous. Let's go ahead and see if we can see acknowledgement synchronous right here. SYN is short for synchronous. Okay, perfect. All right, let's paste that. Boom. All right, two more. All right, so what is the second step in a three-way handshake? So remember that's SYN act, acknowledgement. So it's going to be SYN act. Okay, ACK. Perfect. All right. So what is this acknowledgement? So that's going to be ACK. Okay. All right. So on to task number 5. Trying to go through this quick. All right. So now we get some. Now we get some cool. I believe we get some hands-on now. I guess. So in this stage, blah blah blah. So now we're going to go ahead and start up our machine. So we have our machine. So now if we go ahead and open up a terminal, let's just. That's the. All right, let's just do this really quick. All right, I just put InfoSec Pat's YouTube because this is what this is all about. All right, so let's just make this bigger, and let's go ahead and just ping the IP address here. Let's just highlight this. Oh, see if we can just highlight it. All right, so we can ping it, so that's good. All right, cool deal. So that's working. So now let's go ahead and go back here. All right, what command? All right, so these are probably going to show us about the ping command, like ping Google. Show us some man pages of ping. So ping is just sending a packet to a destination host and to see if it's up, right? If there's a firewall in place, maybe ICMP, ping uses the ICMP protocol. So if ICMP is being blocked, maybe you won't be able to ping it. But let's see what happens. What command would you use to ping BCC to website? So I would use copy. I would use ping and then paste. All right. So if we want to do that, we can just go back to our, let's go ahead and ping, and we're able to ping it. You see that? Here we go. That was pretty simple. All right. So now we're going to go ahead and let's see what ping, blah, 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 what is the IPv4 address? All right. So let's go ahead and take this, copy this, and now let's go ahead and clear this out, and let's ping that. And the IPv4 address is going to be 217.160.0.152. See if we're right. Boom. All right, we're on a roll. All right. Where is it? So what switch lets you change the interval? What switch? I'm not sure what they mean by what switch lets you change the interval. Dash A, I'm guessing. Let's see what they mean by that. The man page. Okay, so let's just look at the man page. Okay. All right. Dash I. All right. So pretty much this is gonna, you know, give us, this is pretty much the, the hands-on stuff. So which switch would you use? Oh, that's dash 4. I know that one. Okay. Which switch? Robust dash V. Okay. So if you're unfamiliar with these, you can just look at on the man pages. But I guess the intervolt, I don't really use that, so I guess I just had to do a little man page. So all right, cool deal. So that was that. So now that was networking tools, right? So the next one is going to be Traceroute. Okay, so let's go ahead and do Traceroute. We're almost done. So Traceroute is sort of like the ping, but what this is going to do is, as it says here, Traceroute can be used to map the path of the request. So, say for example, with Traceroute Google, it's going to go out your gateway, your router, and it's going to go through all the routers until it gets to its destination. Okay, so like it says, by default, the Windows Traceroute utility is Tracecert, operates using the same ICMP protocol, the ping utilities. Okay, so let's go ahead. Let's go ahead and click complete here. Okay. So which switch would you use to specify an interface when using Traceroute? So the interface would be dash I. We would use a dash I. That one I'm familiar with. So let's go ahead and just do that really quick so we can see this little guy in action. So let's do Traceroute. Okay, dash H. Dash help. Okay. So if we come up, we'll probably be able to do the man page too. You know what? Let's just simplify this. Let's grep I dash I. Let me clear this out. I'm getting confused myself. All right. Dash. Let's just do I. It's not going to really give us anything. Let's just see if we can do man Traceroute. All right. So right here we have the dash I for the device, but pretty much this is going to be for the interface. Okay. All right. So which switch would you use if you wanted to use TCP SYN requests when tracing the route? I believe that's dash capital T, but let's make sure. We can go check that in the man pages. Dash capital C. Yep, right here. Okay. Let's just make sure. Perfect. All right. Last but not least, right? Let's do literal thinking. Which layer of the TCP/IP does a trace route when it runs the default gateway? So that's going to be the internet, right? Because the internet's going to go out to the gateway. The gateway is going to go out to the internet. Sorry. All right, perfect. So now we're going to use the tool Whois. This is going to be a fun one. Let's go ahead and do that. So what is Whois? you have domain names, like google.com. Maybe you remember like 8.8.8.8 is for Google's DNS server, but say, all like TryHackMe, HackTheBox, VulnHub, you know, abc.com or whatever, you're not going to remember all the IP addresses. A name is a lot easier. So this is what DNS does for us, right? Like who is bbc.co.uk, and it's going to give us who's the registrar, the relevant dates, the registration status, the name servers, etc. All right, so perform a who is search on facebook.com. Okay, so let's go ahead and do that. Let's clear this out. Oops. So we do who is, or my, who is Facebook, facebook.com. Okay, so if we come all the way back up, we can see all the information for facebook.com. Okay, so let's go ahead and see. So which is the register code for, all right, so it's actually for the register code, postal code, which is probably the zip code. So right here, let's go ahead and see if this is correct. 94025. Okay, perfect. All right, so when was facebook.com registered? So let's go ahead and just give that a go and see when it was registered. So the creation date right here. So it's going to be the 23/29 1997. So let's see, 29/03/97. Hopefully it's like that because they're in England, or they do it a little backwards. All right, so now we're going to do it on Microsoft. Okay, so let's complete that. What city is, so now we have to do a Microsoft. Let's copy this. Okay, who is Microsoft.com. Okay, perfect. So now we're going to go ahead and give this a go. Okay, so which city? Let's go ahead and look at the city. Let's go all the way up. The city, tech city. Okay, Redmond. Let's go ahead and just paste this here, see if that's the answer. Boom. Okay. So now we're going to do some OSINT, right? So what is the name of the golf course that is near the register address Microsoft.com? Okay. So let's go ahead and just do some OSINT. Let's just go to Google. Okay. So what was it? Golf club. What was it? Golf club. What? Yes. So let's just put golf club near Redmond, Microsoft. Okay. All right. So let's. All right, what is it? That's it. Okay. So let's click on maps. Okay. So we have. All right, let's see if this is. All right. This looks like it's pretty close. Let's just copy this. But it can be. Oops. Let's go back. I have no idea if this is it. Let's just give it a shot. Oh, all right. Cool. All right. So now the last thing, what is the registered tech email for Microsoft.com? So let's go back to here. Tech email. Okay, right here. msnhst@microsoft.com. Copy this. Paste. Submit. Please be right. Oh, awesome. All right. So the eighth task is going to be dig. This is a Linux command. All right. So we talked about domains in a previous task. Now let's talk about how they work. Okay. So like I said, I'm not going to read all this. So pretty much DNS, what I was saying, it uses a IP to a server name. Okay. So dig google.com at 1.1.1.1. This is Cloudflare's. IP, I believe. So let's just go ahead and let's give this a shot. What is DNS short for? That's going to be domain name system. So domain name system. Perfect. All right. So what is the first type of DNS server? Wait, what is the first type of DNS server your computer would query when you search for a domain? So that's going to be cursor, I believe. Let's just make sure. Um, let's just go ahead and I believe CMU recursive. Let me just think this. Yeah. All right. Perfect. So bringing me back to the basics, and sometimes I just have to check on myself, right? This is why these things are good. So, what type of DNS server contains records specific to a domain extension .com, etc.? Use the long version of the name. So that's going to be like, so say for example, Facebook.com, TryHackMe.com. That that record is going to be the top level domain, right? So you have a subdomain, top level domain, right? So let me just put top level domain. What? It's going to be top level domain. Is it like, oh, right here. So it has a dash. My bad. Let's just do that. Sorry, folks. All right, perfect. All right. So where is it? Where is the very first place your computer will look to find the IP address of the domain? That's going to be your local cache, right? That's going to look locally first to see, and that's when it goes to like, then that goes out to your DNS server, and your DNS server goes out to the internet. So let's do a local cache. Let's make sure that's correct. Perfect. All right, we're getting along. All right, research. Google runs two public DNS servers. One of them can query 8.8.8.8. This is what I was just saying. What is the IP address of the other one? I know that off the top of my head. I believe if it hasn't changed, it's 8.8.4.4. 8.8.4.4. Perfect. All right. So if a DNS query has a TTL, which is a time to live, of 24 hours, what is the number of digitals shown? Oh, that's a good one. Is that 80? I want to guess right now. Yes, but I believe it showed it up here. I believe it will show it up here. Let's just see. Can't believe I remembered that. That was a wild guess. Just like how many ports there is, 65,000, whatever. But all right, cool. So that's that, and that is it. Congratulations, we've completed this room. So this was the introductory of networking. Hopefully, it's been informative for you guys. If you have any questions, feel free to reach out. I just didn't want this to go on and on and on, so I just wanted to complete it. But that was a fun one. Hopefully, you guys enjoyed it. Until next time, have a beautiful day.